In your earlier studies of kinematics, you learned how to describe motion using displacement, velocity, and acceleration. But kinematics only tells you how objects move, not why. This unit introduces dynamics and statics. You are moving beyond treating objects as simple point masses and beginning to analyze real, extended bodies that translate, rotate, and even sink. Mastering these concepts is absolutely non-negotiable for an A-star, as they form the bedrock for almost all subsequent mechanics topics in the Cambridge syllabus.
Before you can balance forces, you must be able to identify them. We begin by cataloging the fundamental pushes and pulls, from normal contact and tension to friction and viscous drag. Then you will learn to locate the exact center of gravity for irregular objects. This is a vital skill for predicting when a tilted system will topple, and it frequently appears as a visual trap in Paper 1 multiple-choice questions.
When forces act at a distance from a pivot, they cause rotation. You will calculate the moments of single forces and the torque of couples. More importantly, you will apply the principle of moments to prove absolute static equilibrium. This means meeting two strict independent conditions: zero resultant force and zero resultant moment. You are almost guaranteed a major Paper 2 calculation where you must choose your pivot wisely to eliminate unknown forces, allowing you to solve complex loaded beams and vector triangles. Next, we transition from solid mechanics to fluid mechanics. You will start by quantifying how mass is packed into a volume with density, and how normal force is distributed over an area to create pressure. From there, you will derive the exact hydrostatic pressure equation, uncovering how and why pressure increases with depth in liquids and gases. Tracking your units carefully here is the secret to securing full marks. Finally, you will uncover the physical origin of upthrust. Because pressure increases with depth, fluids exert a larger upward force on the bottom of an object than the downward force on its top. You will use Archimedes' principle to calculate this upthrust as the fluid density times gravity times the displaced volume. This proves mathematically why massive steel ships can float, and exactly what determines if an object will sink. By the end of this unit, you will have mastered the mechanics of both solids and fluids. You will be ready to draw perfect force diagrams, balance moments for systems in equilibrium, and calculate pressure differences exactly as the examiner demands. Let's get started.